In our vast universe, few destinations hold as much intrigue as Jupiter, a colossal giant surrounded by enigmatic satellites. At the forefront, unraveling the secrets of Jupiter and its moons, is the Jupiter Icy Moons Explorer, or JUICE. This ambitious mission, equipped with cutting-edge technology, is a combined effort of more than 18 countries and is poised to revolutionize our understanding of the cosmos. Join us as we embark on a voyage spanning over 800 million kilometers, 450 million miles, a daring expedition that will journey through the treacherous radiation belts of Jupiter, dive into the swirling storms of its atmosphere, and reveal the secrets hidden within the icy realms of its captivating moons, Ganymede, Europa, and Callisto. Galileo was the first to observe Jupiter's moons. In 1610, with his homemade telescope, Galileo took a look at Jupiter and saw 4 moons, initially thought to be stars, orbiting Jupiter. These 4 moons were later named Ganymede, Europa, Callisto, and Io. Over 350 years later, in 1989, NASA launched the Galileo space probe in his honor. This was the first spacecraft to orbit Jupiter and more deeply explore its moons, which it did from 1995 until 2003. The data collected by Galileo was quite remarkable. Magnetic field readings of 2 of Jupiter's largest moons, Ganymede and Europa, revealed the existence of massive subsurface oceans, hundreds of kilometers beneath each moon's surface. How incredible is that? These subsurface oceans are thought to be so large that they could swallow up all the water on Earth, with plenty of room to spare. Besides the Galileo probe, only one other spacecraft has ever orbited Jupiter, and that's Juno. It's been orbiting and collecting data on the gas giant since 2016. While both missions have deepened our knowledge of the Jovian system, there's still a lot of unanswered questions concerning Jupiter and its many moons, particularly in regard to the possibility of life. The real question, in our opinion, is why JUICE didn't happen sooner. The European Space Agency, ESA, decided on May 2, 2012 that JUICE would become its main priority. However, the probe didn't launch until April 14, 2023. If you think 11 years is too long to get this mission off the ground, just wait till you see how much juice this probe is packing. With a clear plan to explore Jupiter's moons, the ESA contracted Airbus to build a spacecraft capable of completing the arduous mission. Such a probe would redefine space exploration, and boy did they nail it. The spacecraft weighs an incredible 5,300 kilograms, 11,685 pounds, with its propellant alone weighing over 3,000 kilograms, 6,614 pounds. It also carries 10 state-of-the-art instruments for analysing Jupiter's moons and assessing their capacity to support life. These instruments include everything from cameras and spectrometers to ice-penetrating radars and altimeters. One of the most daunting parts for the construction team must have been building solar panels strong and large enough to power a probe going as far as 740 million kilometers, 460 million miles away from the Sun. To achieve this, they built the largest solar array system to be used on a planetary mission. The solar array is larger than a badminton court, stretching 85 square meters, 915 square feet. The probe packs 10 solar panels, 5 on each side, with a total of 2,356 solar cells. This is hopefully enough to power all of the probe's instruments for the duration of its journey. The instruments had to be protected by a shield, as the area surrounding Jupiter is chock full of harsh radiation, which can easily destroy any unshielded equipment. The spacecraft also has to be designed to withstand the extreme temperatures that it will encounter along the way. So that 11-year window is probably making a lot more sense now, right? Oh, we mustn't forget about RIME, JUICE's radar for icy moon exploration, one of the most important instruments on the probe. This radar is the instrument that can ascertain the position of subsurface oceans and other information crucial to the mission's objectives. Now that we've covered the specs, let's talk about the flight path. As we mentioned before, JUICE was successfully launched on April 14th, but not everything went swimmingly. JUICE's large size meant that some of its components had to be folded and tucked away in order to fit inside the launcher. Following launch, JUICE was expected to unfurl itself within 2 weeks, but during its final stages, something horrifying happened. During the unraveling process, the probe's rime, that very critically important instrument essential to the entire mission that we were mentioning earlier, failed to deploy. It was discovered that a pin holding the antenna in its folded position got jammed and was preventing the antenna from fully extending. Thankfully, after 3 entire weeks of nail-biting tension, Mission Control was able to fix the problem, and now JUICE has officially begun its 8-year journey to Jupiter. Yes, you heard that right. 8 years. JUICE is not expected to reach the Jovian system until 2031. Why does it take so long? The first spacecraft to reach Jupiter was Pioneer 10, which got there within 640 days. Pioneer 11 beat that record, reaching Jupiter in only 606 days. So why is JUICE taking 8 years? Unlike flyby crafts like Pioneers 10 and 11, orbiters have to move more slowly and with greater precision in order to be pulled in by their destination planet's gravity. The Galileo orbiter spent 6 years getting to Jupiter, and Juno spent 5. The difference in time can be attributed to the change in Jupiter's position relative to Earth. Also, orbiters don't take a direct route to their destinations. They usually take a grand and exaggerated tour through the solar system, picking up energy and speed from planets in the form of gravity assists as they travel. A gravity assist is a technique in space travel that allows a spacecraft to gain momentum from a planet by traveling in the same direction as that planet. You can think of a gravity assist like a nitro boost that you typically get in a racing game. Gravity assists are ingenious and essential to long-distance space travel for saving fuel, saving weight, and saving costs. But they most certainly do not save time. When a spacecraft approaches a planet at the right speed, it gets pulled into the planet's orbit and is sort of flung around by the planet's momentum. The spacecraft absorbs some of the planet's momentum and uses this to escape from the planet's orbit at a higher speed and at a new trajectory. For JUICE, its massive size means it'll need all the assistance it can get. To reach the Jovian system, it will steal 4 gravity assists. The first gravity assist, which is expected to take place a full year after launch in August of 2024, will be a really special one. After completing 1 solar orbit, JUICE will perform a flyby of the Moon and Earth in 1 loop. This will be the first ever lunar Earth orbit and will require precision on the part of the ground team. The next assist will be from Venus in 2025, 2 years into the mission, and JUICE is headed in the wrong direction. Oh boy. We told you this would be a crazy flight path. Its remaining 2 assists will come from Earth, one in September 2026 and the other in 2029. This means JUICE will not be en route to the Jovian system until 6 years from now. Wow. You wouldn't want to tag along on that ride. Following the final gravity assist, JUICE will enter a lengthy cruise phase that will last several years. During this phase, the spacecraft will use its propulsion system to make course corrections and maintain its trajectory toward Jupiter. After the long cruise phase, JUICE will execute a critical engine burn in order to slow down and be captured by Jupiter's gravity. Once in orbit around Jupiter, JUICE will begin its true mission, performing multiple flybys of Ganymede, Europa, and Callisto. JUICE will focus the least amount of attention on Europa, with only 2 planned flybys of the Moon. This is because by 2031, NASA's Europa Clipper is expected to have done most of the heavy lifting. This will allow JUICE to focus on its primary target, Ganymede. Ganymede is Jupiter's largest moon and the largest moon in our entire solar system. It's also the only moon to have its own magnetic field. In fact, measured disruptions in the magnetic field confirm for scientists the magnitude of Ganymede's subsurface oceans. Similar to Earth, this magnetic field also creates beautiful auroras at the north and south poles of the Moon. What's more interesting, though, is Ganymede's potential to support life. Scientists speculate that there might be microbial life present within the waters of Ganymede. But before JUICE can orbit Ganymede, it'll have to complete 21 flybys past the third and farthest of the 3 icy moons, Callisto. Sometimes referred to as the Dead Moon for its lack of geological activity, Callisto's unchanging surface is thought to be 4 billion years old, making it the oldest in the solar system. And even though it was long considered to be quite boring, data from the Galileo probe has confirmed the likelihood of a subsurface ocean, which puts Callisto on the list of possible places life might exist. JUICE will get as close as 200 kilometers, 124 miles, to Callisto's surface in order to analyze the moon in greater detail. Finally, JUICE will fly by Ganymede 12 times before making the moon its final resting place. ESA plans to crash JUICE into the moon upon successful completion of its mission. Scientists suspect that Ganymede's subsurface ocean is the deepest of the 3 icy moons, making any potential contamination from a surface crash by JUICE unlikely. Now, you might be saying, wait a minute, JUICE is travelling billions of miles on its journey to and around the Jovian system, and it's not going to tell us anything about Jupiter itself? It absolutely is. JUICE will collect atmospheric data about the planet that the Juno probe is not able to ascertain. JUICE's sub-millimeter wave sounder and spectrometers will provide totally new information about Jupiter's climate, its weather patterns, and the precise chemical components in its atmosphere. We wish JUICE good luck and safe travels on its 8-year journey to the Jovian system, and we look forward to all the secrets it will reveal. The knowledge gained from JUICE will guide our efforts as we strive to unlock the mysteries of our universe and venture beyond our own blue planet. Considering the potential for life on Jupiter's moons, what ethical considerations should we keep in mind as we explore these distant worlds? Let us know what you think in the comments.